To answer the question, why should people consider big data applications, it's very important to know why big data is that important to businesses, because what you have to imagine is you have competitive advantage over other companies as soon as you start to use big data in an efficient way. I would just mention a couple of case studies I was showing just before the presentation. It's like at the New York Times, the analyst there, Nate Silver, he predicted each state correctly out of 50. He said that chance of Obama winning the election is at a result of 99.9 something %. So he did that by using a lot of data, which and a lot of mathematical analytics stuff. And he could do this just like companies could probably also gather data and make good information, valuable information, because value is a very important part of big data. A challenge for big data applications is to transfer data into valuable information, because you can collect a lot of data, which might be good, but the thing is the data correct you are collecting? And if the company figures out what data to collect and how to transform it to valuable information, the company can definitely get competitive advantage over others. So that's a very important fact for big data. You can gain more insights into marketing, into your business marketing. You can target customers more effectively by using big data. Nowadays, marketing is pretty tough. We are overloaded with marketing. So if you just imagine how much marketing you get for Christmas, for the Christmas season, or for other events, the question is, what would you buy? What advertisement would you reflect to? And there is so much competition between different companies going on, and you have to find a way how to make better use of your data you already have and to target your customers more efficiently to gain, once again, competitive advantage. And there are other possibilities, like you could improve your products by what are your customers using in your products, why are they so happy about the products, and you should make them buy even the next version of your product. Like if you develop a software with analyzing data, what you could figure out is, why is your software product good and popular, and why is it not? What could you change in order to make it more interesting? You could do this by different analytics and other things. So there are a couple of possibilities. You can make big data effective for you and to make it profitable for you, to have a return on investment, because it's all about return on investment. And the saying what I often hear is big data or analytics is basically not it's a cost center. It's not true, it's a profit center, but a profit center in a different way. Because if we talk about big data or analytics, it's profit at the end of the day. You have to invest money, but you always have to invest money at a certain point. But you will get more out of that, and that's the challenge. That's what you can do. There are a couple of difficulties, but you have to overcome them. So what we also see in big data applications a lot is the need for different technologies. But why is there this need for different technologies? We have this boom, it's called NoSQL or new SQL, but why is it getting so tremendously important? The thing is, if we look at a technology or a pattern I recently explained, it's a CAP theorem. The CAP theorem says there are three major things in databases nowadays. It's consistency, availability, and partition tolerance. And the CAP theorem says that you can only achieve 2 out of the 3. And no single database could do 3 out of 3 so far. And if you have if you have to distribute a database, you have to use partition tolerance, because partition tolerance means that your database is able to actually partition your data over different clusters. And if you have a lot of data, you have to take that into account. And if you have partition tolerance, what else would you need is availability, so you can't achieve consistency. This means traditional databases as we know them now just simply might not work for you. So you have to use a different database technology. This leads to the fact that using a different technology, you might have some parts of the data in a relational database, other data in a NoSQL database. You might have 4 or 5 different databases. here we have this thing that in the end of the day, it leads to a huge variety of data. And this data is represented in different forms. So that's a challenge for big data applications. But on the other hand, you can have even more use cases defined. If you use the database that serves your needs better, then you can be more performant probably. So if you utilize NoSQL databases in a way that serves your business needs, like if you have a huge scaling problem, if you need to scale out and increase your data all the time, so then NoSQL databases might be helpful for you. But you also take into account you have different databases. Different databases means more formats. More formats means if you do an analysis on top of that, you somehow have to figure out how to get all the data from the different databases and transform it to the right information. And this is another challenge we have. So big data doesn't consist of a single technology. It's not a single thing you can buy. So you can't go to a big vendor and say, hey, I want to have big data. Can you give it to me? They will say, okay, what exactly you want? Because there's not such a thing as you can just go and buy big data. It's not a technology. It's more of a concept. Same as with cloud computing. You can't just go somewhere and say, okay, I want to buy cloud computing. It's a concept once again. The thing is, if we talk about big data, we have to take into account that there are 4 different levels. The first level is the infrastructure level. For big data, it involves, of course, data, and you need to store data somewhere. You need to analyze this data, but how would you analyze the data? You would analyze the data simply by utilizing compute power. It can be GPU-based, it can be CPU-based, or whatever. You might use Hadoop clusters to do that. So you need infrastructure. Infrastructure also often means that it's distributed over various servers, various nodes. So you have to take into account networking and all other stuff. You have to take care of switches. So it involves a lot of infrastructural work. Then the next level of big data is the thing we have to see, where do we store this data? As I answered earlier, you always have to figure out what kind of database you're going to use, what kind of database technology you're going to use, and you might have different levels, different databases actually in your environment, and you have to figure out how they work together and what you do with the databases you have. Or you might have legacy software, legacy databases which come from old systems and stuff like that. So you have to figure out how is your company organized in terms of the database layer. The next is the analyzation and the decision making, which are the next 2 levels. So you have to analyze the data. There are a couple of technologies available for you. A common one is for analyzation is you would run a MapReduce analysis, or other vendors provide good stuff. So there are a couple of technologies available. Then you need to do the decision making. You can do the decision making by presenting the things, or by automating decisions, or even by doing it in a presentation and decide with the board of directors. So there are, at some point, often people have to decide on top of that. Just imagine algorithms in banking systems. If you want to invest in a company, a lot of data might help you seeing if this company will provide you good money in the future. But if you invest, you might rather want to have that information or that decision done by a human.